Have you ever just hit a brick wall trying to connect two different external networks through your ACI fabric? It's a classic problem. You want ACI to be the heart of your network, but getting it to pass routes between, say, your main data center and a partner network can be a real headache. Well, the answer is a super powerful but often misunderstood feature: Layer 3 transit routing. In this explainer, we're going to break that all down and show you exactly how to make your ACI fabric the smart, central hub it was always meant to be. Let's get into it.
First, we'll start with the fundamentals. What even is transit routing? Then we'll jump into the two main ways you can configure it. After that, we're going to unpack a really important concept called subnet scopes. And finally, we'll take everything we've learned and apply it to a real-world troubleshooting problem that you can actually use.
All right, so first things first. Before we get into the weeds of configuration or start troubleshooting, we have to be on the exact same page about what Layer 3 transit routing actually means inside of ACI.
You can think of your ACI fabric as a neighborhood full of dead-end streets. Without transit routing, a car can drive into a cul-de-sac and then back out to the main road, but it can't cut through to another street on the other side. That's what we call a stub network. Well, transit routing turns that cul-de-sac into a major four-way intersection. It basically transforms the ACI border leaf into a smart traffic cop, letting routes and actual data flow between totally different networks, making ACI the true hub of your network.
And this diagram? It shows that problem perfectly. We've got a partner router on one L3 out and a legacy router hanging off another. And the goal is pretty simple. We want the partner router to be able to talk to the networks behind the legacy router, and vice versa. We don't want ACI to just be a final destination. We need it to be the superhighway that connects these two worlds.
So how do we actually build that superhighway? Well, ACI gives us two main and really effective ways to tell the fabric to start advertising or exporting routes between these outside connections. Let's break them both down.
So we have two main tools in our toolbox for this: the default export route control profile and the export route control subnet scoop. Now, both will get the job done, but they kind of represent two different ways of thinking about the problem. You've got the classic, really granular approach versus the more modern, intent-based method. Let's see which one makes sense for you. So first up is the route control profile. If you come from a traditional networking world and you love your route maps, you are going to feel right at home with this one. This method gives you incredibly detailed, policy-based control over exactly which routes you're advertising out of an L3 out. And this is really where the magic happens. Look really close at the name there, default export. That's not just some random name we came up with. It's a special keyword that ACI is actively listening for. When you create a profile with this exact name, you're telling ACI, hey, pay attention. The policy inside this profile is for exporting routes. In this case, we've set up a policy to allow two very specific prefixes. It's a simple idea, but it's an incredibly powerful way to control your routing announcements.
Okay, now for our second method. And this one feels a lot more, well, ACI native. Instead of building a separate policy that looks and feels like a route map, we just declare what we want to do directly on the subnets themselves, right there under the external EPG. With this approach, we're taking a much more direct path. See those highlighted subnets? We've just told ACI, hey, these two prefixes right here, I want you to advertise them out to other L3 outs. By setting that scope to export route control subnet, we're just stating our intent, plain and simple. It's a really clean and straightforward way to get this done.
Now, that brings us to what is, I would argue, the most critical concept you have to master for L3 outs, scopes. See, when you define a subnet in an external EPG, you have to tell ACI what its purpose is. Is this subnet for routing? Is it for security policies? Getting this classification right is everything, and getting it wrong is probably the #1 mistake people make.
This table lays it all out pretty clearly. First, you've got export route control subnet. That's what we've been talking about. It tells ACI, advertise this route out. Second is import route control subnet, which does the opposite. It's for filtering routes ACI learns coming in. And third, and this is so important, is external subnets for external EPG. This one has nothing to do with advertising routes. Its only job is to identify traffic so we can apply a security contract to it. 3 totally different jobs, 3 different scopes. Okay, think of it this way. Exporting a route is like putting a new address into your car's GPS. Great, you now have a path to get there. But that doesn't mean you have the key to open the front door when you arrive. That's what contracts are. Contracts are the key.
They unlock the door and actually permit the traffic to flow inside. You absolutely need both to be successful. You need the route for reachability, and you need the contract applied with the correct scope for permission.
All right, enough theory. Let's put all this to the test with a real-world troubleshooting scenario. This is a classic problem that trips up even really experienced network engineers when they first dive into ACI. So here's our setup. We have one ACI border leaf that's acting as an OSPF area border router. It's connected to a router in Area 0 and another router in Area 1. And the mission? It's simple. Get the routes from Area 1 to show up in Area 0 and the other way around, with ACI serving as the bridge in the middle.
So, you've checked all the boxes. Your OSPF neighbors are fully up. You've even been proactive and applied a contract between the two external EPGs. On the surface, everything looks perfect. But then you log into router 1, you check the routing table, and you hear crickets. Nothing from router 2. It's a classic head-scratcher. What are we missing here?
And this is where things get really confusing. On the left, in APIC, you're getting the green light, the OSPF state says full. But on the right, the router's command line tells a completely different and very empty story. It's a classic case of the lights are on, but nobody's home. The control plane seems healthy, but the data plane is completely dead. So what's going on?
And there it is. That's the fundamental truth of the ACI fabric. This is not a bug. This is a core security feature. ACI is built on a zero-trust model. It will never pass routes between two different L3 outs by default. It assumes, for security, that they should be kept separate unless you explicitly tell it to do otherwise.
So the fix is really just a direct application of everything we've been talking about. First, double-check that each of your OSPF neighbors is in its own separate L3 out. Second, you have to explicitly tell ACI to advertise the routes. Pick your method. Either use that default export profile or set the export route control subnet scope. Super important. You have to do this in both directions. And finally, make sure that contract is in place with the right subnet scope to actually let the data flow once the routes are there. So let's lock in the key takeaways here. Number 1, and if you remember nothing else, remember this. ACI is default deny for transit routing. You have to turn it on. 2, you've got two great tools for the job, the default export profile for that fine-grained control and the export route control subnet scope for a more direct approach. 3, subnet scopes are everything. You have to classify them correctly for both routing and security policy. And finally, when you're troubleshooting, the routing table is your ultimate source of truth, not just whether the neighbor is up. You know, we started this explainer just talking about how to connect your network through ACI, but now you have the tools. And the real power comes from combining this routing control with ACI's security model. By being super precise about which routes get exchanged and which conversations are allowed with contracts, you can build these incredibly secure, segmented networks where only the traffic you intend to flow can ever flow. That is the real power of ACI, and now you know how to unlock it.